Good evening, Zimbabwe. Good evening, everyone. Welcome back to BST African Electronic Surgery. And you know, it's very, very late, but we don't have option except to fix some few urgent jobs. So what we have tonight, we have some kind of new items which we have to fix. Like what I said, I'm trying to look for the gadgets, electronic devices which I have never fixed, and try to apply the electronic knowledge to fix those gadgets. So what we have tonight, that's the guy. That's the guy. I don't even know this thing. I never used it. And even on the market, I never seen such kind of thing. But let's try to read and try to figure it out. What thing exactly? It was booked in as no power. It's written Power Master. And here we have AC input, that's the input, and here we have DC output, automatic battery charger. I suppose this thing is charging some heavy duty batteries, maybe some car batteries, maybe. And here we have another sticker, input voltage 230 AC, output voltage 24 volts DC 10 amps. Okay, so let's put the AC voltage 220. That's my AC cable. Let me test it. 231, that's fine. Let's plug in, on. Let's switch. We do have a switch. Okay. We have the green light, and we must have some output voltage here, I guess. Almost 0 voltage. We don't have any power there. Okay. Okay, let me test again. To me, testing at once is not enough. 0.20, 0.15, almost zero output. But you can see the green light, which indicates that this I can call it heavy duty battery chargers on for some big batteries. We must have output voltage 24 volts and check 0. All right, let's get inside. I don't even know if you can fix this one, but we can try, you know. It's an electronic device, and it must be fixed. It must be fixed. Let's try to find out what is inside this thing. Let's try to find it out if we can. Top cover. Okay. We have the AC input voltage, which is coming here. Here you can see the input, and after the input we have a fuse. That's the fuse here. That's 10 amps fuse. Okay, After that, we have some filters, that's not important, some thermistors on the high voltage area. After that, it's going straight to the rectifier bridge. This one which is changing from AC to DC. After the rectifier bridge, we have some filter capacitors, big capacitors, 200 volts, which are probably connected in series to give us 400 volts, maybe. We have the chopper, that's the big transformer, another chopper here. And on this heat sink, we have some MOSFETs. Okay. And here we have some capacitors on the output to filter voltage. So it's just a basic switching power supply, nothing complicated here. But through visual inspection, check this capacitor as a bump, this one as a bump, and this one is also blown up. So let's take this one out, maybe we can. So from the visual inspection, what did we see by now? We have 3 capacitors blown up. I have this thing, and these some wires on the output. Maybe I have this chip. I don't even know what the chip is. Let's cut this one. 1 second. Let me cut this. I need to check some few things if I can. First, let me go on microscope. Well, this chip is blown up. I don't even know what kind of chip is this, but we can check under microscope. Let me put my microscope on focus. L7812. L7812. Okay. What kind of chip is this? Is it a regulator? Let's check. 7812, 12 volts regulator. L7812 voltage regulator. Voltage regulator data sheet. Maybe we can find something online. Maybe. Just maybe. L7800 output voltage 5, 8, 9, 12, 15 up to 24 volts. Okay. Nothing special about this chip, it's just a regulator. What I want to check more, I want to try to look for the pin out, pin voltage, pin configuration. That's very important. Okay. Visit. Let's open 1 second. LM78112, that's our regulator. Pin number 1 input, pin number 2 ground, pin number 3, that's the output of the regulator. Okay, so this regulator is supplying up to 20 volts. That's why they use this regulator on the output. Okay, so we have the three capacitors which are blown up, and our regulator 7812. That's our regulator on the output to ensure that we have a stable voltage there. So where can we start? Let's take out those capacitors. I think that's a good point to start. Just to take out all these capacitors if we can. Let's try to do it quickly, as quick as you can. Okay, let's take them all. We need more soldering wire here, just to speed up the process here. Let's put more soldering wire and try to take out these capacitors quickly, because time is the key, you know. All our capacitors are out so quick. Okay, what kind of readings do we have here? 1050 volts, 1050 volts, 1050 volts. So you can see this capacitor, all these capacitors are gone. Capacitors should not have a bump on top. Those capacitors, they are blown up, they are all gone. But I don't think if you replace all this capacitor, our battery charger is going to work well, because we have two faults here. We have the issue of, first one, capacitors, they are blown. The second, the chip probably, which is regulating some power on the output, is blown up. So before replacing those capacitors, I'm curious if I can find this regulator 7805. Where can I find this regulator? Any idea? Any idea? 7805. I think I once have this kind of things. 1 second. Let me switch to microscope, because I can't see clearly this one. L78112. L7812. That's the one. That's the one. Okay. So we now have our regulator. This one, I just found it. Let's put it there. And I do have some capacitor. I don't think here I can find this capacitor with such kind of values here. 50 volts, 470. The capacitance is too low. Probably this will not last longer. So let's try, because long ago I used to build a lot of funny things, switching power supplies. So I think we can do some tricks here if we fail to get the capacitor. What about going back in time and try to apply the physics law, you know? Okay. What do we have here? We have 35 volts. 35 volts. 16 volts. You can see this capacitor. I was building some circuit long back. All this capacitor, you can see. I was taking this capacitor from other engines and building some circuit, and we are lucky. If I checked some capacitor and failed to get the exact value, I was connecting the capacitors in series. So here, I think we are lucky, but I don't know if that's gonna work on this one. But let's try to modify the manufacturer's schematics and put some capacitors in serial connection. You can see these capacitors, they are connected in series. Why? Because we don't have 50 volts. The other one is 25 and the other one is 25, 1000 micro, 1000 micro. Meaning to say we have 50 volts, 2000 micro. According to me, it's a better modification according to what the manufacturer did. So let's modify things here. Can we? Let's modify things here. Just have hope, you know. Let's modify things here. Because I don't have these capacitors, 50 volts, 1000 micro. So it's better to use those capacitors which are connected in series. I was building a lot of funny things because that's the only best way to learn electronics. Where's our minus? Our minus is on the outside. So what are we supposed to do here? How are we supposed to do it? No, this side minus. Let's fix the plus. Okay, that's the first one. What about this one? 35 volts, 1000. 16 volts, 1000. That's 51 volts, 2000 micro. Okay, I'll put it like this. There's nothing to change here. I'll put it as it is. Let's modify the schematics of the manufacturer here. I'm just curious to see if this gonna work on this one. That's what I was doing 10 years ago, you know. 10 years ago I was building funny things. We have one more left. One more left. Where's the plus of this one? The plus is on this side. Let us see the last one. What kind of values do we have here? Here we have 35 volts, 1000 and 16 volts. That is 51 3.2 micro. That should be fine. Let's modify things here. Let's modify things. I know we can do it. We can do it. Let's use electronic knowledge, you know. The physics law. If you connect capacitors in serial mode, obviously the value will increase. Minus on this side. Let's fix the minus thing first. Fixed. The plus is fixed. So all our capacitors are in place. You can see. Let's leave like that. Let's move on to our regulator. Let's go again and check the pinout configuration of 7812. Pin number 1. That's the input. Okay, that's our regulator. Pin number 1, that's the input. Let's put our test meter on continuity mode. I want to check something. From the minus of the capacitor, let's check those wires and see which one is connected to ground. The black one is ground and this red one on the plus. Okay, the red one is connected on the plus, which is the pin number 3, which is supposed to be connected to the output. So let's do it. Let's try to, I need soldering wire just to speed up things here. I need more soldering wire. Let's do it. I don't know if that will solve the problem. These are some kind of new jobs, fixing something which you don't even know. I don't even know this thing. I've never used one, but it is an electronic device. What we can do, I have nothing that I have to do here except to fix it. Okay, let's sort out. That's our regulator. Let's start with the input. Input pin number 1. Pin number 1. Okay, let's sort out the ground pin, middle pin, middle pin, let's sort out the output thing. Okay, all seems to be okay. So that's what we have here. Where are my capacitors? This one. I want to put it in a place so that I can able to test this one. I think all what is left is to test. Let's power off. Let's plug in AC. Will this gonna smoke or not? Must have faith here. No smoke. Okay. Voltage. Output 0. Before the diode 35 volts. On the plus of the capacitor 23 volts. Why? Did we miss something? Where is the... Okay, let me check something. On this cap, plus minus 34. Okay. Let me check something. Because if we do have voltage on the filter capacitor on the output, but we don't have voltage here. Here we do have a fuse on the output. Yes, that's a 15 amps fuse. We can check that fuse. It's a good idea. Maybe the fuse is gone. Who knows? The fuse must be like this. 0, 0. But check here. So, if we go back in time, when we checked, there was a... on this blown up regulator, which was on the output. When this regulator blown up, the fuse also got bent. So this fuse is not good. So let's fix the fuse thing. We can put a nice bridge here. It's nothing special, it's about a fuse. Let's come with our own fuse here. Our soldering wire fuse. Okay. Let's check. Because I'm curious, All what I want is to see this device working. And then this capacitor is not a good deal. It's not a big deal. I will see what I shall do. Maybe I will stick with hot glue. That's not a big deal. If we are able to bring back our device to life, power, AC, power on, you can hear the fan is just started spinning. And if we check now on the output, check 27.9 volts. So our heavy duty battery charger, whatever it is working fine. No issues. So let me power off. The MOSFETs are getting hot because they are not under heatsink. So our thing is fixed. our thing is fixed. What I need to do, I want to stick these things properly with hot glue, you know. That's the best I can do to put everything together with hot glue. And after that, we can close this device. So we modified a few things here, and we still have a working device, which is good, because it's not about I don't have space and I'm not fixing this device. No, it doesn't work like that. You have to carry on the repair thing, no matter what. No matter what, the repair thing must continue. Because after all, the customer, what they want results rather than explanations. So this thing, I'll give customer 3 months warranty. It's fixed. There are no issues here. I'm just sticking those capacitors with the hot glue, which I connected in serial mode to carry more voltage, for the simple reason that I don't have the exact value for this 50 volts 1000 micro. I don't have them. So should I return the gadget to the customer unfixed? Is that a good thing? I'm just insulating everywhere with hot glue. Let's come with the top cover, how it is supposed to be. An idea, so like this, I think so, or maybe like this. Yes, let's put back all those things if we can. And after that, we can test again. Just want to put back all these screws quickly because I'm racing against time. It's now late, so all I want to do is to put back everything here, and then after let's stick this switching MOSFET on the heatsink. I'm quite happy, you know. If you are fixing something which you don't even know,
That's quite good. That will give me a nice feeling, you know. Nice feeling. Our regulator, which I put 7812, is on heat sink. It's not even heating up, which is a good thing also. So let's do it. I know it's late, but that's what I choose. That's what I choose to do in life. Electronics. So I have to do electronics. I have to do it. Because I choose, no one forced me. And it's very hard, especially in my country. In my country and in my city, actually, to get people with adequate electronics knowledge. People, you go with your device to a repair shop, they checked. Some, they don't even mount meters. All what you can see is just those you see the Chinese, those Chinese guns, soldering guns, the cheap ones, no multimeter, no adjustable power supply, and they will be writing we are fixing phones, we are fixing TVs. No, it doesn't work like that. The best thing is to learn electronics. That's the catch. Learning electronics, you will never go wrong, because you will fix anything. Any gadget, you can do something, rather than learning fixing phones. It's not good, because we have some limitations. Obviously, learning electronics, you get more money, because you fix anything. This thing, I don't even know what it is, but it's fixed. How should I put this? Like this? Okay. Let's just finish up and test one more time. So that's the catch. Fixing phones or learning fixing phones only is not enough. Of course, you fix phones, but what about learning electronics? Because if you learn electronics, you can fix phones, you can fix TVs, you can fix radios, you can fix inverters, you can fix anything. You can fix even computer box on automatic cars. So I think we just finish up. Let's plug in our power. Let's power on. Fan is spinning at full speed. Let's check again the output voltage. Minus, plus 27 volts, which is fine according to me.
So our gadget is working fine. So you can hear the sound of this fan, some LED lights. So this thing is fixed. Let me power it off. So yeah, we did some modifications. We carry on with our repair, and we shall try to find out more harder jobs than this one. So if you are not yet subscribed, just go on YouTube to our channel BST African Electronics Surgery, subscribe, like our videos, turn on the notification key for future updates. See you on the next one. Bye.